All right, so welcome to Critical Thinking Week 2. Today we are looking at Chapter 2, which introduces you to some of the terminology that's used in logic and critical thinking. And so we've used the term argument last week, but I wanted to kind of start off here, just as the book does, by talking about it because it is the primary unit that is used in critical thinking and logic. It's what we're dealing with, are arguments. Now, a lot of people think they understand what an argument is. An argument is when two people get into a heated dispute and start yelling back and forth at each other. Well, certainly that's a type of argument, but it's not the argument that we're dealing with in terms of logic. And so if we look on the board here, you'll see a good definition of argument in logic is a series of connected statements intended to lead to a logical conclusion. In other words, what an argument really is in its technical sense is someone giving pieces of evidence, statements of evidence, which are trying to get you to accept some conclusion that maybe you wouldn't otherwise accept. They're trying to prove it to you in some way. And so that's really what an argument is. And so as we go through the course here of critical thinking, and even if you go on to take courses in logic, you're going to find the same basic issue, which is that an argument is going to be trying to prove something to you, and it's giving you evidence that should be linked together to lead you to that conclusion. Okay. Now, the basic unit that we're dealing with in critical thinking and logic to get us to the argument is what's called a statement. Obviously, arguments are going to be made up of statements. Now, a statement is a very specific type of sentence. It's also many times called a proposition. We talked briefly before about how that second form of logic that was created was called propositional logic. And that's really because all of the statements that are made within it deal with this type of reasoning. So a statement or a proposition is a specific type of sentence that makes an assertion. It's making a claim of some sort, and because of that, it has a truth value assigned to it. If you think about what we talked about last time with the principle of bivalence, right? Logic depends very heavily on the principle of bivalence, the idea that every statement is either true or it is false. Therefore, you know that a statement that doesn't have a truth value is not going to be of any use in the field of logic and critical thinking. So I have on the board here 3 different sentences. Bob is tall. Why is Bob tall? Bob, stop being tall. Each one of these qualifies as a sentence. However, only the first one is going to qualify as a statement. This statement, Bob is tall, is making an assertion. It's making a claim. And so we could say Bob is tall. That's true. Or we could say Bob is tall. That's false. Depends on how tall Bob really is and who we're comparing him to. But the other 2 are not statements. Why is Bob tall? You wouldn't respond true to that. Doesn't make sense. It's asking a question. And likewise with the last one, Bob, stop being tall. You wouldn't say, Bob, stop being tall. That's false. Right? There's no assertion that's being made there. Instead, what you have is what's called an imperative. It's making a command. It's telling you to do something. So again, in logic, we are only going to be concerned with that type of statement, one that has a truth value to it, one that is making an assertion, one that's making a claim of some sort. Now, in your book on page 15, there's exercise 2-1, and the idea here is just to use this to try to determine what is a statement and what is not. And I'm not going to make a big deal out of this because I think that it's a fairly easy, straightforward thing, but let me just go through a couple of them with you. The first one says, please close the door. Well, please close the door is kind of like Bob, stop being tall. It's asking you or telling you to do something, but it's not making an assertion. There's no truth value, so it's not a statement. Number 2, on the other hand, says, if you don't close the door, the dog will get out. Well, in this particular case, it seems to be making a claim of some sort. It's telling you that if you fail to close that door, the dog is going to get out. And that's a statement that seems logically to be true. So since it makes an assertion, it has a truth value, it's a statement. Number 3, read chapter 3 before the next class. Again, that's making an assertion, that's making a command, or it's telling you to do something. There's no truth value there, so it's not a statement. Why is the sky blue? Okay, again, like why is Bob tall? It's asking a question. There's no truth value, there's no assertion being made. Therefore, it is not a statement. 5, mushrooms are the summer homes of elves. Okay, even though it's a rather silly statement, it is still a statement. It's making a claim that mushrooms are, in fact, the summer homes of elves. And even though we would declare that to be false, most likely, the fact is that it's still a statement because it's making an assertion. It has a truth value assigned to it. Okay. If anybody has any questions about that, feel free to email me and I will deal with it a little bit more. But I think for the most part, you guys should have the right idea with regards to this. Okay. The next thing that I want to look at is the fact that there are different types of statements that are used in logic. We have what are called premises, premise or premise statements. And those are statements that are offering proof. They're intended to back up or prove the conclusion. Okay. So a premise or premise statements are statements offering proof. They're intended to back up or prove the conclusion. And so it's the evidence that you're giving. And that might be another good word to use there, evidence that's being presented, because a lot of this book, of course, is focusing on court cases, so the use of the word evidence kind of makes sense there. But the premise statements are going to provide that evidence. They're going to give you some reason for why you should believe the conclusion. And then, of course, the conclusion, the other type of statement, is what you are trying to prove. So it's the thing you're trying to prove. So when we look at the statements that we have in an argument, there is going to be a bunch of premise statements. There might only be one or two, but there could be a lot of premise statements because it depends on how much evidence or how much proof you need to back it up. And then the conclusion, there's usually only one conclusion statement, and that's the thing that you're trying to prove. Now, how do you tell the difference between a premise and a conclusion? Well, one way, of course, is simply to ask yourself whether or not you would readily accept what is being stated there. Because the conclusion will probably be something that's more controversial, something that needs proof. Whereas the premise or premises will be statements that are easily verified or things that are common knowledge, stuff you would more readily accept. So that's one way of doing it. We also have a series of words that we can look to, and these words will help us to determine whether or not something is a premise or a conclusion. If you see words such as therefore, thus, hence, so, words like that are what we call conclusion indicators. And so the statement that immediately follows that is what we call a conclusion. So therefore, blah, 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 thus, blah, blah, blah. Whatever that blah, blah, blah is, that is the conclusion because it follows one of these key words. And there are actually a lot more of these words you can look for, but the book here only gives you a small number. So those are the ones we're going to take a look at in that respect. Now, in terms of premises, there are also important premise conclusions that are given there as well. The big one, probably the biggest one, is since. We see that one a lot. Right? Since this occurs, then, okay. Because is another one that we use a lot. Due to the fact that. Right? And you can kind of see how those would lead you to a premise. Right? Due to the fact that X happens, Y is going to be the result. Because X happens, Y will be the result. Since X happens, Y would be the result. Okay, what immediately follows those key words or phrases is going to be a premise. So these words lead you to the conclusion. These words lead you to the premise. And so that's probably the easiest way to be able to determine what is an argument and what isn't. I'm sorry, as far as determining what's the premise or what's the conclusion of your argument, is to look for those key words. You can also then verify it by saying, all right, well, here, I think this is the conclusion. Does that sound like a controversial claim that needs to be proven? You know, or this is supposed to be the premise, so does this sound like something that I would be willing to openly accept, that I would readily accept? So looking for those key words. There is one other thing that can kind of lead you to it as well, and this is because when we look at the arguments, they don't always have indicator words. A lot of times they do, and that makes it really easy, but if they don't, in English, the likelihood is that if there are no indicator words whatsoever, the likelihood is that the first sentence is going to be your conclusion. And the reason for that is because in English we tend to argue in one of two ways. We either start off by listing all of our evidence and then the conclusion, putting it at the end. But if we do that, we usually say, okay, here's my evidence, therefore here's the conclusion. Or we start by giving the premise first. Start by giving the conclusion first, and then going on to give the reasons why we should accept that conclusion. Now, if your conclusion is first, then it doesn't make sense to start off by saying therefore when you haven't said anything before it, right? So 99% of the time, if there are no indicator words in your argument, you will find that the first sentence is going to be the conclusion. So an argument then, of course, is going to have those elements, and it's going to try to prove something. If you look on page 17, section 2-2, you have a series of things there in the exercises, and it basically wants you to know, to determine, are these arguments or are these not arguments? Well, I'll take a look at a couple of these just so that you can kind of get a feel for what is and what isn't an argument, but I also want to break down one or two of them so that you can see the difference between premises and conclusions. So the first one says, if the moon is made of green cheese, then there are mice on the moon. The moon is made of green cheese, therefore there are mice on the moon. Well, if I look at that, it seems that there is an argument that's being presented there. It looks like there is evidence that's being given in some way to try to get me to accept the conclusion that there are mice on the moon. And I know that there are mice on the moon is the conclusion because I see the keyword therefore. And that tells me that what we're dealing with is, in fact, an argument that is trying to prove a point, trying to prove a claim. Now, to evaluate, and this is something you'll see later on, but I may as well give it to you now, we have what's called standard form. And standard form is a way of writing out your argument to make it easier to see, to make it easier to visualize. And basically the idea is that you're going to have your premise or premises, however many you have, 1, 2, 3, whatever, and they will be listed along the top here. There's a line, and that line implies therefore, and then what's below the line is the conclusion. This makes it look very much like a math problem. If you think about a simple math problem, 1 plus 1 equals 2. Well, what exactly does that say? It says that if I take what's above the line and stick it together, I'm going to have what's below the line. In other words, the conclusion of this math problem is already here in the premises. It's just stated in a different way. It's the same thing in logic. The evidence, the conclusion is already there, contained within the premises, just like the number 2 is already there, contained within these premises. It just needs to be brought out to be made more precise or more clear. It's just stating it or restating it in a different way is all that's happening. Okay, so that's the idea behind standard form. So if I wanted to put that argument that I just read to you in standard form, it would essentially say, if the moon is made of green cheese. I'm going to shorthand here a little bit. Then mice are on the moon. Second premise says the moon is made of green cheese. Therefore, our conclusion, there are mice on the moon. Okay, and that's what that argument would look like in standard form. And the benefit of having it in standard form is that when you learn how to evaluate the arguments to see whether they're good or not, it makes it a lot easier to visualize, again, putting it into that so that it kind of resembles the idea of a math problem. Again, I'm kind of getting ahead of things a little bit, but if we were to kind of consider what's being said, the first premise tells us that if it's the case that the moon is made out of green cheese, then there are mice that are going to exist on the moon. So if I accept that statement as being true, and I accept the second premise as being true, that the moon is made out of green cheese, then I have no choice but to accept that the consequent follows from it. And so if the premises are true, which granted they're not, but if they were, it would force me to accept the truth of that conclusion. Which means that actually the argument itself, even though it doesn't logically make, it doesn't make sense in our common parlance, in terms of the logic, the structure is good. The structure makes sense, okay? But we'll see the difference between that a little bit later on. Number 2, I solemnly swear to tell the truth, the whole truth, and nothing but the truth. There's no argument being presented there. You're just making an oath. Number 3, raspberry surprise ice cream has big chunks of real fruit. What a combination. Rich ice cream with delicious fruit. It's my all-time favorite ice cream. That's not really an argument either. What you have there is somebody making an endorsement for a particular product or something like that. Number 4, Wheaties is a nutritious cereal. After all, Mary Lou Retton appeared on Wheaties advertisements, and Mary Lou Retton is certainly healthy, so Wheaties must be nutritious. It's another example where it's not really a great argument, but it is an argument. We have the premise telling us that Mary Lou Retton appeared on Wheaties advertisements and that Mary Lou Retton is a healthy individual. So based upon that evidence, they want us to conclude that Wheaties must in fact be a nutritious type of cereal. So the premises are leading you to that conclusion. Again, I think this part is relatively straightforward, so I'm not going to give you any homework to deal with on those, but if anybody has any questions, again, please feel free to email me about that. All right. Well, this brings us to an important distinction with regards to arguments themselves. Within logic, there are two specific types of arguments. One is called a deductive argument, and one is called an inductive argument. Okay. And it's important to be able to distinguish these because they're going to be evaluated slightly differently, and there's a little bit different terminology that's involved in each of those. Now, with a deductive argument, you are dealing with certainty. If your premises are true, you will be forced to accept the truth of the conclusion. There's no way around it. Okay? If the premises are true, you are forced to accept the truth of the conclusion. With an inductive argument, you're dealing with probability. If the premises are true, there's going to be a certain likelihood that the conclusion is true or that the conclusion follows from it. But it's not certain. It's not absolute. I'll give you a couple examples here. All humans are mortal. Socrates is human. Therefore, Socrates is mortal. Now, that's an example of a deductive argument because if these premises are true, you will be forced to accept the truth of the conclusion. And it's just like I was explaining before about how the conclusion is already contained within the premises. So let's draw this out so you can see. All humans are mortal. So let's say this box represents all mortal beings, all mortal things. And this box represents all human things. So every human that exists is inside this box. And this box of human things is inside the larger box of mortal things, hence all humans are mortal. Well, Socrates, we're told in the second premise, is a human. So we put Socrates inside the box of human things. The box of human things is already inside the box of mortal things, which means, of course, that Socrates is in that larger box of mortal things. So if the premises are true, you have no choice but to accept the truth of the conclusion. That's deduction. Okay. So here's an example then of an inductive argument. And again, with induction, you're dealing just with probability, with a likelihood that the conclusion follows. So it says Socrates is human and mortal. Aristotle is human and mortal. Xanthippe is human and mortal. Therefore, all humans are mortal. Well, again, if we assume the premises are true, does that necessarily force us to accept the conclusion that all humans are mortal? No. There are 7.5 billion people on this planet, and we've looked at 3. Just because 3 have these characteristics doesn't mean that all 7+ billion of them do. So it's not a question of certainty like we have over here. Instead, it's a matter of probability. It's making a best guess. And so I might say, well, if my evidence is true, then it follows that my conclusion is probably true. But I can't know that with certainty. I can't know that for sure. To know that all humans are mortal, I would have to analyze every single human that's ever existed in order to make that determination. And if I found even one that wasn't, then my conclusion would be wrong. But the more evidence that I have to back it up, the stronger the claim becomes when you're dealing with induction. Okay. So in this case, this is actually a pretty weak argument because, again, we've only looked at 3 people out of 7.5 billion on the planet now, not to mention all those that have come before and have existed in past times. If I had, said, hey, I've examined 1 million people, and all of those people are human and mortal, that would be a much stronger argument. But it would still be induction. It would still be a matter of a best guess. And that's what induction is. It's making a best guess based upon the evidence that you have. But it also comes with the realization that you might be wrong. Whereas with deduction, there's an absolute certainty there. If those premises are true, you must accept the conclusion. There's no doubt about it. Now, the thing is, of course, that certainty and deduction, that's what people like because they want that type of certainty. But as you see, deduction doesn't really do anything to give you new evidence because the conclusion's already pictured, it's already there within the premises. And so most of our knowledge is actually going to come to us through induction. We learn primarily by formulating a hypothesis and testing it and seeing if it works. But if it does, how many times do we do that before we say, oh, it's going to work? Okay. The Scottish philosopher David Hume, in the 18th century, he talked about what he calls the problem of induction, which is that a lot of times inductive reasoning looks at the past in order to make a prediction about the future. We take an example such as this. I have this marker and I release it, and the marker falls. And I've done that many, many times, and every single time I've released the marker has fallen. So I build up an expectation or a belief that every time I release the marker, it's going to fall. But the fact is that that doesn't necessarily have to be the case. The marker that it could just be a matter of coincidence that one thing has happened as a result of, or one thing has happened following another. It doesn't necessarily mean that one is the cause of the other. Okay. So the more times we see something happen, the more we build up the likelihood or the expectation that it's going to continue to happen. But that doesn't mean that with absolute certainty that it always will. I expect, and if I were a betting person, I would bet money that every time I release the marker, it was going to fall. But Hume would remind us that it's possible that all of this has just been a matter of coincidence, and that at some point in the future, maybe something alters or changes in the universe, who knows what, but maybe the next time I go to release it, it floats instead of falling. We just don't know for sure, because most of our knowledge is simply based upon this idea of induction, that I say, look, it happened in the past, therefore it'll happen again in the future. Or I've taken a sample of the group, and what applies to the sample of the group is going to apply to the whole. But again, all of that is a matter of guesswork. It's intelligent guesswork, but it's still guesswork. Okay. So on page 20, exercise 2-3, we have, again, a series of arguments here, and I guess some of them it says are arguments, some of them are not. But for the ones that are arguments, they want us to know what is the premises, what is the conclusion. So let's take a look at the first one here. And it says, all licensed physicians in the United States are medical school graduates. Ralph is not a medical school graduate, so Ralph is not a licensed physician in the United States. Well, clearly, that sounds to me like it would be an argument, and we're trying to reach the conclusion that Ralph is not a licensed physician in the U.S. But is it an inductive or a deductive claim? Well, this seems to be a deductive argument. First of all, if you notice, the first statement is a categorical statement. All licensed physicians, every single one. And we're going from that universal claim of all down to a particular claim of Ralph, this one person. And many times when you have that movement from the universal down to the particular, you have a deductive claim, just as we saw with going with all humans being mortal down to Socrates being mortal. Whereas with induction, a lot of times you go from the particular to the universal. So like with the example we had, we looked at those three particular individuals, and then we tried to make a universal claim about the whole. So that's one way of perceiving the difference between them. But in this case, it goes from the all down to the individual Ralph. So all licensed physicians in the United States are medical school graduates. So let's kind of draw this out here. Here's your medical school graduates. And every licensed physician is a medical school. So here's your licensed physicians. Every licensed physician in the country is in that box, and all of them are inside the bigger box of medical school graduates. Now, Ralph, we're told, is not a medical school graduate. So Ralph is outside the box of medical school graduates, which means logically that he's also outside the box of licensed physicians, which is inside the bigger box of medical school graduates. So in this case, we know that if those premises are true, we will be forced to accept the truth of the conclusion. So this is a deductive argument form. Number 2, if you want to live a long and healthy life, then you should eat lots of fruits and vegetables and stay away from junk food and fast food. Also be sure to get some exercise and try to get a decent amount of sleep. And of course, don't smoke. There's not really an argument that's being presented here. This is more a series of instructions that's being given. It's more along the lines of imperatives rather than statements or arguments. So we'll move on to number 3. Susan is a licensed physician and she's a medical school graduate. Sarah is a licensed physician and she's a medical school graduate. Sam is a licensed physician and he's a medical school graduate. Bradley is a licensed physician and he's a medical school graduate. Teresa is a licensed physician. She's a medical school graduate. Ralph is a licensed physician, so he is probably also a medical school graduate. All right, well, this is an argument, and it seems to be trying to argue that Ralph is a medical school graduate. If you look at it, you see that we start with a series of individuals, but we're not really building towards a universal idea. We're building towards still another particular. But actually, it is kind of universal because the argument's trying to say that, look, all of these people who are licensed physicians are medical school graduates. So it seems likely that since Ralph is a physician, he must also be a medical school graduate. what you have with number 3 is going to be an inductive argument. Okay, because again, look at what is being said here. We've got like 6 different people are licensed physicians and medical school graduates. Ralph is a licensed physician. Therefore, we want to believe that Ralph is a medical school graduate. Okay. Now, maybe, Ralph is old enough that he was back from the days where a person could apprentice, and maybe he didn't actually go to medical school to graduate. Maybe he just apprenticed and still was managing to become a licensed physician. There could be some rare instance like that, but generally speaking, it seems logical to believe that if the premises are true, there's a very, very good likelihood that that is probably true as well. And of course, you've got the very word probably right there in the conclusion, so that really sort of indicates as well that what you're dealing with is an inductive argument form. But that's basically one of the things that you're going to need to know is, can you tell the difference between what is deductive and what is inductive? So I am going to give you some of these to play with. So the first of your homework, you're going to have a couple assignments here, but the first of your homework is on page 20, this exercise 2-3. And I did the first 3, so I'm going to have you try 4 through 10. So 4 through 10, basically all you have to do again is to figure out whether it's an argument or not. And if it is an argument, is it an inductive argument or is it a deductive argument? Okay. And now that we've seen how to distinguish between what's deductive and what's inductive, now we can get down to the business of evaluating these arguments to see whether they are good arguments or not. And the reason, as I said, for distinguishing between deductive and inductive is the fact that there are different ways in which we evaluate them. So I'm going to start with deductive arguments. Okay. So we start with deductive arguments. With a deductive argument, you're going to be looking for 2 things. The first thing you're going to check for is what's called validity. Okay. Is the argument valid or is it invalid? Okay. Now, one of the hardest things to get through to people is this. When you are testing validity, you do not actually care whether the statements make any kind of sense at all. You don't care whether they're actually true or false. Instead, you always assume, no matter what it says, always assume that the premises are true. And so you are asking yourself, just as we did a moment ago, if these premises are true, do they force me to accept the conclusion? If they do, then it's valid. If they don't, then it's invalid. So a valid argument is one where true premises force true conclusion. An invalid argument basically is going to be anything else, but essentially the true premises do not force true conclusion. Okay. So if we take a argument here, all cats are feline. All leopards are cats. Therefore, all leopards are feline. Okay. So there's an argument that we're going to look at, but let me give you another one. All cats are dogs. All pigs are cats. Therefore, all pigs are dogs. Okay. Now, when we look at these two arguments, our mind immediately says to us that this one we want to accept and this one we want to reject. But in reality, when you're talking about the validity of the argument, the fact is that they are identical arguments. You'll notice that in both cases, they are universal affirmative claims, all are, all are, all are, all are, all are, all are. And if we look at our positioning here, we have cats in the subject of your first premise, as well as in the predicate of your second premise. And the same thing over here. We have the word feline in the predicate of your first premise as well as in the predicate of your conclusion. Here we have dogs in that position. And over here we have leopards in the subject of the second as well as the subject of the conclusion. Here we have pigs in that position. And so basically, if you look just at the structure without worrying about what the words are saying, look just at the structure, you have in both cases all square are circle, all triangle are square, therefore all triangle are circle. Okay? That's the structure. That's the form of the argument. And if it helps you, feel free to go ahead and do that, where you replace the actual words with A, B, and C, or replace the actual words with squares, circles, and triangles, so that you're not thinking this makes sense and this doesn't, because in validity you don't care whether it makes sense or not. You're looking only at whether or not the premises, the logic of it works. Will the premises force true conclusion? We have no idea what the squares, circles, and triangles stand for. They could be these words, or any combination, as long as what's here is also here, what's in this spot is also in that spot, and what's in that spot is the same as what's in that spot. And so if I evaluate this, these true premises, I'm going to assume they're true. So, all the circles, whatever they are, is in that box. All the squares, whatever they are, is in that box. Every triangle is a square, so the triangles are going to be there inside the box of squares. Well, if that's the case, are we forced to accept that all triangles are circles? Absolutely. We have no choice. And so regardless of what it actually says, we're looking just at the structure, the form of the argument. And we assume, no matter what it says, we assume the premises are true. Will those true premises force the conclusion, as we have here? Yes. Therefore, the argument form is valid. And that's what we want to see as a valid argument, one where true premises will force a true conclusion. Okay. All right. Okay. So here's, no, sorry. So here's another argument. All cats are feline, all cats are dogs, therefore all cats are feline. Again, regardless of what you know or don't know about animals, start by assuming the premises are true. If they are, will they force you to that conclusion? Well, first premise says all cats are feline. So there's your box of felines, and every cat that exists is inside that box of feline things. All cats are dogs. Here we have a box of dogs, and we're told that every cat is a dog. Now, the problem here is that when we diagram these two statements, we don't see the connection, we don't see the link that exists between them the way that we did with the others, right? So every cat is a feline, so every cat is inside the box of feline things. Every cat is inside the box of dogs. But does that necessarily mean that dogs and felines are one and the same? There's not something up there that specifically gives us that, which means it seems that we just don't know. It could be true, it could be false, but it doesn't force us to accept that conclusion. It's not that the conclusion is not directly contained in the premises the way it was with that one. And so this is what we call invalid. And an invalid argument is a bad argument that you basically just want to get rid of. Okay, so that's the first thing you're concerned with, is validity. Is the argument valid or is it invalid? The second thing that you're going to look for is what's called soundness. Okay. Is the argument sound or is it unsound? Okay. And what you want in logic for a deductive argument is to have a sound argument. That's the goal. That's what you're looking for. So how do we get a sound argument? Well, to be a sound argument, first it has to be valid. That's why you check validity first. If it's an invalid argument, it's automatically unsound. So to be sound, it has to be a valid argument. But it also must actually have true premises leading to a true conclusion. Okay. So this is where it actually matters whether or not the argument is, whether or not the statements are true or false. This is where you actually check. With validity, you don't care. You just assume truth. With soundness, you're actually verifying, is this statement really true or is this statement false? Okay. So to be a sound argument, which is what you want, it has to be valid, and the statements actually have to be true. For an unsound argument, if it's an invalid argument, it's automatically unsound. So all invalid arguments are unsound. Or, secondly, it could be a valid argument with any false statement. Okay. So an invalid argument is unsound, but also a valid argument that actually has a false statement of any type is going to be unsound. So the argument I had about all cats are feline, all leopards are cats, therefore all leopards are feline, that one, as we saw, the structure of the argument is valid, and the premises that were stated are all true, leading to a true conclusion. So that would be an example of a sound argument. That's the ideal. That's what we want to see. The other one I showed you, we said was invalid. Since it's invalid, it's automatically going to be unsound. this one, I think it was, all cats are pigs, all dogs are cats, therefore all dogs are pigs. I think that's what I made up, or very close to it anyway. That one, as we saw, if the premises are true, you are forced to accept the truth of the conclusion. So it is valid, it fits that form. However, when you actually test the truth value, all cats are pigs is not true. That's a false statement. All dogs are cats, that's also a false statement. So you've got false premises, at least one. You've got more than one, but at least one, which means that even though it's valid, it's going to be unsound. So you would call this valid but unsound. Okay. And those are essentially the options that you have in deduction. You can have an argument that is valid, basically an argument that is valid and sound, a sound argument. That's what you want. That's a good argument. If you have an argument that is valid but unsound, like this one is, it means the structure, the form of the argument is good. However, the statements are off, so maybe there's something you could do to play with it, to fix it, maybe not, to make it into a good argument, but at least you know the logic behind it, the structure is sound. And you have an argument, of course, that is invalid, and if an argument is invalid, there's nothing you can do with it, just throw it away. It's an awful, awful thing. All right. So that's the terminology as far as deductive arguments are concerned. Now, we want to turn to inductive, which if you understand the one, you'll understand the other. They're very, very similar, but the language is a little bit different because, again, you're dealing with probabilities instead of certainty. So with an inductive argument, the first thing you're going to look for, not validity, but rather strength. Okay. Is the argument strong, or is the argument weak? Okay. Now, just like validity, with strength, you're not concerned with whether it's actually true or false. You start by assuming your premise is true. A strong argument is one in which true premises, they can't force it because it's not deduction, but true premises lead to a probably true conclusion. Okay. So a strong argument is where true premises lead to a probably or very likely true conclusion, and a weak argument is going to be one where the premises do not lead to a probably true conclusion. Okay. So again, you're looking just at the structure or the form of the argument. Okay, so here's an example of an inductive argument. 95% of all deaf people have no musical talent. Beethoven was deaf, therefore Beethoven had no musical talent. Well, again, forgetting what you know or don't know about music, We simply start by assuming the premises are true, whether they are or not, and asking ourselves whether or not it seems likely the conclusion follows from it. Well, 95%. So let's draw a little box here. There's 5%, and there's 95%. We're told that 95% of the people have no musical talent, and that means that the 5% have musical talent. Beethoven is deaf, right? So this represents all the deaf people. 95% of which have no musical talent, 5% of which have musical talent. Now, if we're playing the odds, right, we don't know for sure where Beethoven would fit. If we don't know who Beethoven is, we don't know where he would fit in these two categories. But playing the odds, the likelihood is that he would be in the 95% who have no musical talent. There's a much greater likelihood that he's going to be here than in the 5%. Therefore, it seems likely that the conclusion that he had no musical talent would follow as being probably true. Okay? So based upon just the structure or the form of the argument, we would find that the true premises, if the premises are true, and again, we have to assume that they are, they will lead us to a likely true conclusion. There's a much greater likelihood that he has no talent than that he does. And so we would call that a strong argument. Okay. If the argument said 5% of all deaf people have no musical talent, Beethoven was deaf, therefore Beethoven had no musical talent, well, at that point, right, the 5% are the ones who don't, the 95% are the ones who have. Therefore, where is it more likely that Beethoven's going to be? If he's deaf, he's going to be right here in the 95% again, which are those that have musical talent. So, in this instance, if it's true that 5% of deaf people have no musical talent, it's true that Beethoven was deaf, it doesn't seem very likely that Beethoven was part of that 5%. It seems much more likely he's part of the 95%. Therefore, we would say under those circumstances, it's probably false. So you have true premises leading to a probably false conclusion. That would make it weak. Okay? So it's, in a lot of cases, it's simply a matter of playing the odds. Is it strong or is it weak? So that's the first thing you're testing is strength. The second thing you're going to test is called cogency. Is the argument cogent or is it uncogent? Okay. In cogency, just like soundness, is where it actually matters whether the statements are true or false. And again, the setup is really very similar. To be a cogent argument, and that's what you want in induction is a cogent argument, it first has to be strong. If it's a weak argument, it's going to be uncogent. So to be cogent, it has to be strong, and it must actually have true premises leading to a probably true conclusion. Okay? So to be cogent rather, it has to be a strong argument. That's why you test strength first. And there must actually be true premises leading to a probably true conclusion. To be uncogent, well, if you have a weak argument is automatically uncogent. But you could also have a strong argument with any false statement. So the argument that I had presented to you here 5% of all deaf people have no musical talent. Beethoven was deaf, therefore Beethoven had no musical talent. We saw that was a weak argument. It's weak, it's automatically uncogent. Because all weak arguments are uncogent. The other argument that I had, 95% of all deaf people have no musical talent. Beethoven was deaf, therefore Beethoven had no musical talent. We saw that was a strong argument because it led to a probably true conclusion. However, if we start to evaluate this, I have no statistics on this, but I would assume that the statement that 95% of all deaf people have no musical talent is false. So we've got at least one false statement. And although it's a matter of opinion, the statement that Beethoven had no musical talent, I would say, would be pretty much universally considered as false as well. But the point is, even though it's a strong argument, it has at least one false statement, which means that it is also uncogent. So just as with the deductive argument, what you wanted was a valid sound argument. With induction, what you want is a strong cogent argument, right? A cogent argument. That's the ideal. That's a good argument. That's one you want to use. If you have an argument that is strong but uncogent, then again, it means the structure is good, but you may have to play around with the words a little bit. And of course, if you have an argument that is weak, just throw it away. It doesn't serve any purpose to anyone. It has no value to us at all. All right. So let's go ahead and take a look at page 25. We have exercise 2-4. And here we're going to be given a series of arguments. And we have to determine whether they're deductive or inductive, and then evaluate them accordingly. Valid, invalid, sound, unsound, etc. So, the first one says all stars produce energy. The sun is a star. Therefore, the sun produces energy. All right. So it looks to me like, again, we're going from a universal to a particular. It looks like we have an argument here that is going to be a deductive argument form. So that means, since it's deductive, we're going to test first for validity. Is it valid or invalid? So I start by assuming the premises are true. If they're true, will they force me to accept the conclusion? All stars produce energy. So there's all the things that produce energy are in that box. This box, all the stars. So every star is a producer of energy. The sun, we're told, is a star. Well, if the sun is inside the box of stars, and the box of stars is inside the box of things that produce energy, it follows that the sun does in fact produce energy. So if those premises are true, they will force me to accept the truth of the conclusion, which means that what we have here is a valid argument. Now, all stars produce energy. That is actually true. The sun is a star. That is actually true. The sun produces energy. That is actually true. So we have an argument here where it is valid. All the statements are true, which means we have an argument that is valid and sound. Now in the book, it just gives you certain options here. And so option C, this is a sound argument, basically, is the way you would respond. Okay. Number 2, the University of Michigan has reduced its tuition every year for the past 20 years. So probably there will be a reduction of tuition at the University of Michigan next year. Okay. So the University of Michigan reduces tuition for the past 20 years. Therefore, the University of Michigan will reduce tuition next year. So looking at this, we are looking at the past to make a prediction about the future. So we know we're dealing with induction. With induction, we want to know, is this argument strong or is it weak? Is it cogent or uncogent? So again, I start by assuming the premise is true, that Michigan has reduced tuition every year for the past 20 years. If it is true, does it seem likely that they will do so again next year? Yeah, it does. I mean, you've got 20 years of evidence saying this is what they do every year. Therefore, it seems likely that they're going to do it again. So we have an argument that is strong. There seems to be enough evidence here to back up the claim that's being made. Now, has the University of Michigan reduced tuition for the past 20 years? Absolutely not. They've raised it quite a few times over those years. So we've got a false statement that's here. False, even though it's strong, because there's a false statement, it means that it's uncogent. So strong but uncogent. And looking at the options they give you, that would be option D for strong but uncogent. Okay. One more. We've got Rover is a dog. No dogs can play bridge. Therefore, Rover cannot play bridge. Okay. Well, it looks like we have a deductive argument, so we're going to treat this as deductive and test the validity. Assume the premises are true and see if they will force the conclusion. Now, when you're dealing with these deductive claims, if you have the alls, the nos, if you have these universal claims, test those, draw those out first, because the order doesn't really matter in terms of the structure here. So I'm going to start with the second premise. No dogs can play bridge. So this box represents all those beings who can play bridge. Now, no dogs can play bridge, so over here we've got this box that represents all the dogs. This premise, the first one, tells us that Rover is a dog. Well, if Rover is inside the box of dogs, and the box of dogs is completely separate from the box of things that play bridge, it would follow that Rover, who is a dog, is not able to play bridge. So, true premises force me to accept a true conclusion. That makes it valid. Now, this one I think is a little bit tricky because the first statement there, Rover is a dog, is that true? Is that false? I mean, yes, Rover is a very common name for a dog. I don't know too many people that are called Rover, but I suppose the potential exists that there could be one. So I'm a little leery on that one. But I'm going to go ahead and give it the benefit of the doubt. I'm going to go ahead and assume that Rover is a dog. I will accept as true that no dogs can play bridge, which means I have to accept the truth down here, that Rover cannot play bridge. So this is valid. The premises, the statements are all true. So this is valid and sound, which again was option C in the text. Okay, so that's the basic idea of what you want to be able to do with this, is simply to be able to evaluate, to tell whether these arguments are valid or invalid, weak or strong, and so forth, based upon looking at what's presented. And I will tell you that one of the problems that I've run into is that sometimes the examples are kind of like this one, and some of them are even worse than that, a little bit sketchy. So if you have to make a guess once in a while, don't worry about that too badly. The examples that I give you for the exams and stuff later on, that's going to be a lot more straightforward. You won't have to do any guesswork in those, but sometimes in the book, there's things like the rover is a dog. You have to kind of make some little assumption in that. So just go ahead and make the assumption, and if you happen to assume something different than I did, that's all right. We'll deal with that. So shouldn't be a problem. So I am going to give you some of these to play with as well. So as far as the homework then, we have on page 20, I already gave you this one. This was exercise 2-3. You were doing numbers 4 through 10. And here on page 25, exercise 2-4, again, I'll give you 4 through 10. I'll give you a little bit of practice with regards to those as well. And then if you turn the page on page 26, you'll see exercise 2-5. And I want you just to try all of those. It's just a multiple choice here, but these are just basically questions to test what you've understood as far as the terminology and things, and what can be done, what can't be done with regards to the class. So that's going to be the homework that is due, and you're going to want to have this submitted have it submitted before class. So I'm going to make the due date, the deadline 11 a.m. Thursday, because Thursday, of course, we're going to have the live class through Collaborate. And during that, of course, I'll answer any questions that you may have for me, and I'll also take the time to go through and work all of the problems, and we can talk about that to make sure that you guys understand what it is that you've done in this chapter. All right. So in Thursday's class, I will go through all of the answers. That's why you need to have them submitted before the class starts. Okay. Remember, again, homework is simply there for you to practice this stuff. Don't worry about it if you didn't get it immediately. That's fine. You get basically you get the points just for trying it. So don't lose those easy points. You're going to get the points just for trying the homeworks. That's all it's going to take. So in any event, this is what you want to do. Get that handled, get that taken care of. Submit it by 11 a.m. Thursday. Again, either submit it directly through Blackboard, which is the best way, or if you can't figure out how to do that on Blackboard yet, you can email it to me. Just make sure I get it where it's dated before 11 o'clock on Thursday. And then we'll see you for the live class via Collaborate at 11 o'clock Thursday. All right. If you have any questions for me in the meantime, then by all means do stop in to email. You can't stop in to email, but come into the screen here and write me a letter through email, and I'll respond to you in that way. All right. So that's it, and you guys have a great day.